Einstein, His Life and Universe by Walter Isaacson. Picture yourself at 16, sitting in class with your mind wandering, but you're not thinking about lunch or the weekend. You're pondering something far stranger. What would it actually feel like to race alongside a beam of light? Would the light wave just hang there next to you, frozen like a shimmering ribbon of energy? Would time itself grind to a halt? This wasn't idle daydreaming. This question sparked a revolution, and it came from a kid whose teacher once told him he'd never amount to anything. A young man who bombed his first college entrance exam, struggled to land a job, and spent his most creative years pushing papers in a patent office. That young man was Albert Einstein. Today, we're diving into his extraordinary journey through Walter Isaacson's masterful biography, Einstein, His Life and Universe. This isn't just a story about physics equations and scientific breakthroughs. It's about a rebel with a cause, a man whose wild hair and twinkling eyes became the face of genius itself. But what is genius, really? Is it just about being smarter than everyone else? Or is it something more mysterious? By the time we're done, you'll understand what really fueled Einstein's creativity. It wasn't just raw intelligence. It was his insatiable curiosity, his defiant imagination, and his willingness to question everything everyone else accepted as obvious truth. He shows us that our most powerful tool isn't what we know, but our ability to wonder. This is the story of how a patent clerk cracked open the secrets of the cosmos and became the conscience of humanity. It's proof that true genius isn't about having all the answers. It's about never losing the courage to ask the deepest questions. So let's begin. Let's ride alongside that beam of light and see where it takes us. Here's something funny about our heroes. One of the most popular Einstein stories is that he failed math in school. You hear it everywhere, usually told to comfort struggling students. Don't worry, people say, even Einstein failed math. It's a comforting story, but it's completely wrong. The truth is, Einstein excelled at math and science. By 15, he'd already taught himself differential and integral calculus. The myth comes from confusion about the German grading system, but the real story is far more interesting. His struggles weren't with the subjects themselves. They were with how they were taught. From his earliest days, Albert Einstein was a rebel. Born in 1879 in Ulm, Germany, to a middle-class Jewish family more interested in culture and education than religious ritual, he was a late talker. So late that his worried parents consulted a doctor. When he finally did speak, he had an odd habit of whispering each sentence to himself first before saying it aloud. The family maid called him the dopey one. But this slow development came packaged with fierce independence. He despised the rote memorization and military-style discipline of German schools. He couldn't stand the drills and the demand for blind obedience. One teacher famously complained that his smiling presence in the back of the classroom undermined everyone's respect. Another declared he'd never amount to much. For most people, this constant friction would be crushing. For Einstein, it became his secret weapon. His contempt for authority wasn't just teenage rebellion. It was the foundation of his scientific genius, giving him the courage to question beliefs in physics that had stood unchallenged for over 2 centuries. He later believed his slow verbal development was actually a gift. While other children quickly learn about space and time and then take them for granted, Einstein came to these ideas late, with fresh wonder. He never stopped being a curious child before the great mystery into which we were born. That wonder ignited with a simple gift. When he was about 5 and sick in bed, his father brought him a compass. Watching the needle tremble and point unfailingly north mesmerized him. No string, no visible force pulling it, just an invisible field filling the space around it. He felt something deeply hidden had to be behind things. That single moment sparked a lifelong fascination with invisible forces shaping reality, a mystery he'd spend his life trying to solve. His mother, an accomplished pianist, gave him another gift that shaped his mind, a violin. At first, he hated the rigid lessons. But when he discovered Mozart's sonatas, music became a passion, not just a hobby, but a way of thinking. He saw in Mozart's pure, logical structure a reflection of the universe's harmony. Throughout his life, when stuck on difficult problems, he'd pick up his violin and play. In the middle of a melody, an idea would come. It was as if music, nature, and the mind of God were all connected, speaking the same beautiful language. His rebellious spirit finally erupted at 15. His father's electrical business had failed, and the family moved to Italy, leaving Albert behind in Munich to finish school. He hated it. Feeling trapped, depressed, and intellectually suffocated, he hatched a plan. He got a doctor's note, claiming nervous exhaustion, left school at Christmas, and took a train across the Alps to join his astonished family. He promised to study independently and get into the prestigious Zurich Polytechnic. This wasn't just about escaping a bad school. It was about escaping Germany's militaristic, authoritarian culture. If he'd stayed, he'd have been drafted into the army, a prospect he dreaded. He renounced his German citizenship and became stateless for a time, a citizen of the world. His first attempt at the Zurich Polytechnic was a disaster. He aced math and physics, but failed subjects like French and literature. On the director's advice, he spent a year at a special high school in the Swiss village of Aarau. It changed his life. The Aarau school was everything his German gymnasium wasn't. Built on a philosophy of encouraging students to visualize images, think independently, and learn through intuition and observation rather than rote drills, it was paradise for Einstein. Here he first performed the thought experiment that set him on his path to greatness. He asked himself that famous question, what would it be like to ride alongside a beam of light? According to theories of the time, a light beam was an electromagnetic wave rippling through a mysterious, invisible substance called the ether. If you traveled at light speed, you should see a frozen, stationary wave beside you. But that seemed impossible. It violated his intuition that physics laws should look the same for everyone, regardless of how they're moving. This paradox, this psychic tension, would haunt him for the next decade. In Aarau, he also found something else he'd been missing, a warm, loving home. He boarded with the Winteler family, who embraced him as their own. He fell in love for the first time with their daughter, Marie. He became more open and developed a witty, sarcastic sense of humor that charmed his friends. After a year, he passed his exams and enrolled at the Zurich Polytechnic in 1896, intending to become a teacher. But his old habits of skipping class and disrespecting professors returned. He found the lectures outdated. They didn't even cover James Clerk Maxwell's groundbreaking work, whose elegant equations showed how light, electricity, and magnetism were all connected as electromagnetic waves. So Einstein taught himself. He and a small group of friends gathered in cafes, reading the latest physics papers and debating the biggest ideas in science and philosophy. They called themselves the Olympia Academy. In these late-night sessions, fueled by coffee and cigars, Einstein sharpened his thinking, questioning the very foundations of physics. He had a close friend, Marcel Grossman, a brilliant, diligent math student who took meticulous notes that he shared with the often absent Einstein. Without these books, Einstein later said, I would rather not speculate on what I would have done. Their friendship would prove crucial not once but twice in Einstein's life. During his Polytechnic years, his relationship with Marie Winteler faded. He'd moved on, falling in love with the only other physics student in his section, a brilliant, intense Serbian woman named Mileva Marek. 3 years older, walking with a slight limp and prone to melancholy, she shared his passion for science and rebellious spirit. They were intellectual soulmates. How happy and proud I will be, he wrote to her, when the two of us together will have brought our work on relative motion to a conclusion. Their romance was stormy and passionate. His parents, especially his mother, fiercely disapproved of Mileva. They saw her as too old, too intellectual, and not Jewish. But their opposition only fueled Einstein's rebellious love. He and Mileva had a child out of wedlock, a daughter named Liesrel, whose existence remained secret for decades. Einstein likely never saw her, and her fate remains one of the sad mysteries of his life. She was probably given up for adoption in Serbia and may have died of scarlet fever as an infant. When Einstein graduated from the Polytechnic in 1900, he was near the bottom of his class. His professors, annoyed by his impudence, refused to recommend him for academic positions. He was the only graduate in his section not offered a job. For 2 years he drifted through temporary tutoring jobs, feeling like a failure. I am nothing but a burden to my family, he wrote in despair. It would be better off if I were not alive at all. His friend Marcel Grossman saved him. Grossman's father knew the Swiss Patent Office director in Bern and recommended Einstein for a position as a technical examiner. In 1902, Einstein got the job. It seemed like a dead end for someone dreaming of unraveling the cosmos, but the Patent Office turned out to be a blessing. The work was interesting, forcing him to think about space, time, and light, as he evaluated patents for synchronizing clocks with electromagnetic signals. And he was so good at it that he could finish his daily work in just hours, leaving the rest to work on his own ideas at his desk, which he famously called his worldly cloister. There, in his spare time, Albert Einstein had one of the most productive years in science history. The year was 1905, his annus mirabilis, or miracle year. He was 26 years old. He produced 5 papers that would change the world. The first, which he considered his most, quote, revolutionary, quote, tackled light's nature. Physicist Max Planck had recently suggested energy might be emitted or absorbed in discrete packets called quanta. But he saw this as mathematical trickery, not physical reality. Einstein went further, proposing that light itself isn't a continuous wave, but is made of tiny energy packets we now call photons. This explained the, quote, photoelectric effect, where light hitting metal knocks electrons loose. It was so radical it would trouble Einstein for the rest of his life. The second and third papers were related, providing a way to determine atoms and molecules, true size, and explaining quote 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 quote. By showing this dance was caused by random collisions of unseen water molecules, Einstein provided the first convincing experimental proof that atoms and molecules actually exist. At the time, their existence was still debated. The fourth paper finally solved the paradox haunting him since 16. Titled On the Electrodynamics of Moving Bodies, it introduced the world to the special theory of relativity. In it, Einstein threw out centuries-old ideas of absolute space and absolute time. He started with two simple postulates. First, the principle of relativity. Physics laws are the same for all observers in uniform motion. This idea went back to Galileo. Second, the light postulate. Light speed in a vacuum is constant for all observers, regardless of their motion, or the light source's motion. These ideas seemed contradictory. How could light speed be the same for someone standing still and someone chasing the light beam at nearly light speed? The solution came in a flash during a conversation with his friend and patent office colleague Michel Bessot. The key was rethinking time itself. Our notion of simultaneity isn't absolute. Two events appearing to happen simultaneously to one observer might appear at different times to another observer moving relative to the first. He used a thought experiment. Imagine two lightning bolts striking a train track at distant points simultaneously. An observer standing on the embankment exactly halfway between strikes will see light from both flashes arrive together. But for a passenger on a moving train rushing toward one strike and away from the other, light from the approaching strike will arrive first. For her, the strikes aren't simultaneous. And if simultaneity is relative, then time itself must be relative. A moving clock runs slower than a stationary clock. An object's length contracts in its direction of motion. Space and time aren't separate and absolute. They're interwoven into a single continuum, space-time. And with this, the mysterious ether supposedly filling all space became, in Einstein's delightfully dismissive word, superfluous. Then, months later, as an afterthought, he published a short 3-page fifth paper. An addendum to his relativity paper, it contained what would become science's most famous equation, E equals mc squared. Energy equals mass times the speed of light squared. This simple formula revealed a profound truth. Mass and energy are two forms of the same thing. Mass is simply highly concentrated energy. Because light speed squared is such an enormous number, a tiny amount of mass converts into tremendous energy. The energy locked inside a single raisin could power New York City for a day. In one incredible year, a young patent clerk had redrawn the universe's map. But the world barely noticed. His papers met what he called icy silence. He still couldn't get an academic job. For 4 more years he remained at the patent office, continuing his work in spare time. Slowly, though, physics giants began taking notice. Max Planck, the grand old man of German science, was first to recognize relativity's importance and began lecturing on it. The recognition was welcome, but Einstein was already moving on. Special relativity was incomplete. It dealt only with uniform, constant velocity motion. It didn't account for acceleration, and it didn't incorporate gravity. Then one day in 1907, sitting in his patent office chair, he had what he'd later call the happiest thought of my life. He imagined a person in free fall, perhaps a painter falling from a roof. During the fall, that person wouldn't feel his own weight. He'd be weightless. An object released from his hand would float beside him. Einstein realized that experiencing a gravitational field is indistinguishable from experiencing an accelerated frame of reference. This was his principle of equivalence. Imagine you're in a windowless elevator in deep space, far from any gravitational pull. If the elevator accelerates upwards, you'll feel pressed to the floor, just as you would by Earth's gravity. Drop a ball, and it will fall to the floor. No experiment inside that elevator could tell whether you're being accelerated or simply sitting in a gravitational field. This simple, beautiful insight was the key to a new gravity theory, but turning this happiest thought into a complete theory would be his life's hardest struggle. It would take 8 more years of intense, grueling work. The math was so complex, he needed help from his old friend Marcel Grossman, who'd taken notes for him in college. "Grossman," he said, "you must help me, or I will go crazy." Grossman introduced him to the complex world of non-Euclidean geometry, the mathematics of curved surfaces. Einstein's breathtaking leap of imagination was this. Gravity isn't a force pulling objects across space, as Newton thought. Instead, gravity is the curvature of space-time itself. The best analogy is picturing a bowling ball on a trampoline. The fabric curves around the heavy ball. Roll billiard balls nearby, and they don't move toward the bowling ball because it's exerting some mysterious force. They move toward it because they're following curves in the trampoline's fabric. Now imagine this happening not on a 2-dimensional trampoline, but in 4-dimensional spacetime's fabric. Massive objects like the sun warp spacetime around them. Planets like Earth orbit the sun not because they're being pulled by a force, but because they're following the straightest possible path through this curved spacetime. The quest to find precise mathematical equations describing this cosmic dance was a race. He was competing against one of the world's greatest mathematicians, David Hilbert. In a frantic 4-week burst of creativity in November 1915, working in Berlin amid World War turmoil and his marriage's collapse, Einstein finally found the solution. One prediction was that it could explain a tiny, mysterious wobble in Mercury's orbit that Newton's laws couldn't. When his calculations produced the exact right number, he was so excited he had heart palpitations. "I was beside myself with joyous excitement," he told a friend. He'd done it. The general theory of relativity was his masterpiece, one of the human mind's most beautiful and profound achievements. It had another testable prediction. Because gravity curves space-time, it should also bend light. A light ray from a distant star passing near the sun should be deflected by a precise amount. This prediction was tested in 1919. British astronomer Arthur Eddington led expeditions to Brazil and an island off Africa's coast to photograph a total solar eclipse. When stars became visible near the sun's edge, their positions were measured. They'd indeed shifted by the exact amount Einstein's theory predicted. The announcement made headlines worldwide. "Revolution in science," declared the Times of London. "Newtonian ideas overthrown." Albert Einstein, the obscure patent clerk, was suddenly the world's most famous scientist. He became an icon, a global celebrity. His face was everywhere. His name became synonymous with genius. His personal life was just as turbulent as his scientific one. His marriage to Mileva had disintegrated. She'd been his intellectual partner in youth, but grew increasingly morose and jealous as his fame grew and her own scientific dreams faded. In 1919, they divorced. In a remarkable act of confidence, he offered her a deal. He promised her money from the Nobel Prize he was sure he'd one day win, if she'd grant the divorce. She accepted. It took 2 more years, but in 1922 he was awarded the Nobel Prize, not for relativity, which was still considered too controversial, but for his photoelectric effect explanation. Mileva got the money. He'd already remarried, to his first cousin, Elsa Einstein. She was Mileva's opposite, nurturing, domestic, and unimpressed by intellectual complexities. "Understanding relativity," she once said, "is not necessary for my happiness." She was his protector, his manager, his gatekeeper, creating a comfortable bourgeois home that allowed the rumpled, absent-minded professor to retreat into his world of thought. As his fame grew, so did darkness in Germany. Rising anti-Semitism, always an undercurrent in his life, now became dangerous. Attacks on him and his Jewish physics grew more frequent and vicious. This profoundly affected him. Though never traditionally religious, he began embracing his Jewish identity with newfound passion. He became an outspoken Zionism supporter, not because he believed in nationalism, he hated it, but because he saw the need for a homeland where Jews wouldn't be considered aliens. In 1921, he made his first trip to America, not to lecture on physics, but to raise money for the cause with Zionist leader Chaim Weizmann. The trip turned him into an American sensation. But this period, in the mid-1920s, marked the great turning point in his scientific life. The quantum revolution he'd helped launch was now being transformed by a new generation of brilliant young physicists, Werner Heisenberg, Erwin Schrödinger, Wolfgang Pauli, and their mentor, Niels Bohr. They were developing new quantum mechanics based on uncertainty, probability, and chance. And Einstein hated it. He couldn't accept that the universe, at its most fundamental level, was governed by randomness. The idea that an electron could choose, of its own free will, when to jump from one energy level to another, or which direction a photon would be emitted, was intolerable to him. This led to his most famous declaration of faith. I, at any rate, am convinced that he does not play dice. This began the great intellectual debate of the 20th century, a series of legendary arguments between Einstein and Niels Bohr. At conferences and in letters, Einstein devised ingenious thought experiments designed to poke holes in quantum mechanics to show it was incomplete. The most famous was the EPR paper, written in 1935 with colleagues Boris Podolsky and Nathan Rosen. They imagined two particles that interact and then fly off in opposite directions. Because their properties are correlated, measuring one particle's property, like its position, could instantly tell you the other's position, no matter how far away it was. This seemed to imply what Einstein mockingly called spooky action at a distance. How could measuring one particle instantaneously affect another billions of miles away? It violated his deeply held beliefs in locality, that an event here can't instantly affect an event over there, and in an objective reality existing independent of our observations. Inspired by these debates, Erwin Schrödinger came up with his own famous thought experiment to illustrate the absurdity, Schrödinger's cat paradox. A cat is placed in a box with a poison vial that will be released if a single radioactive atom decays. According to quantum mechanics, until the box is opened and observed, the atom is in a quote decays of being both decayed and not decayed. Does that mean the cat is also in a superposition of being both dead and alive? For Einstein, this proved quantum mechanics wasn't a complete reality description. Bohr and his followers, however, argued Einstein was wrong. The spooky action was real. The universe is that strange. And experiment after experiment, to this day, has proven Bohr right and Einstein wrong. The great revolutionary had become a resistor. The man who'd overthrown classical physics, certainties, now dedicated his last 30 years to trying to restore them. He embarked on a long, lonely, and ultimately unsuccessful quest for a unified field theory, a single set of equations that could describe all nature's forces, gravity and electromagnetism, and explain particles, existence, and quanta strangeness in a deterministic, orderly way. He was searching for the mind of God. As he was losing physics battles, political battles in the world were becoming more terrifying. In December 1932, as he prepared to leave for a California visit, he told Elsa as they left their beloved country cottage outside Berlin, "Take a very good look at it. You will never see it again." He was right. A month later, Adolf Hitler came to power. Einstein's house was raided by Nazis, his books burned, and a bounty placed on his head. He never set foot on German soil again. He became a refugee, a symbol of intellectual and moral destruction wrought by Nazis. He eventually settled in Princeton, New Jersey, at the newly formed Institute for Advanced Study. He'd found his final home. Hitler's rise also forced him to confront his lifelong pacifism. "As long as I have any choice," he'd always said, "I shall live only in a country where civil liberty, tolerance, and equality of all citizens before the law prevail." Those conditions no longer existed in Germany. He realized that against such evil, pacifism wasn't an option. "I am not only a pacifist, but a militant pacifist," he'd once declared. But now he urged European nations to arm themselves against the Nazi threat. It was a painful but necessary change of heart. Then came the letter that would haunt him for the rest of his life. In summer 1939, his old friend, Hungarian physicist Leo Szilard, came to visit him on Long Island. Szilard and other refugee scientists were terrified that German scientists were on the verge of discovering how to build an atomic bomb. They needed to warn the American government, but knew no one would listen to them. They needed a voice that couldn't be ignored. Einstein dictated a letter to President Franklin D. Roosevelt, explaining the possibility of a nuclear chain reaction and the potential for extremely powerful bombs of a new type. He signed it. The letter was delivered to Roosevelt and helped launch the Manhattan Project. Einstein himself was never asked to work on the bomb. The FBI, under J. Edgar Hoover, had compiled a massive and largely ludicrous file on him, labeling him a security risk because of his pacifist and socialist leanings. He knew nothing about the project until he heard on the radio in August 1945 that a bomb had been dropped on Hiroshima. He was horrified. "Oh my God," was all he could say. He later called the letter to Roosevelt the one great mistake of his life. "Had I known that the Germans would not succeed in producing an atomic bomb," he said, "I would not have lifted a finger." For his last decade, he became a passionate advocate for nuclear arms control and world government. "The unleashed power of the atom has changed everything save our modes of thinking," he warned, "and thus we drift toward unparalleled catastrophe." He knew nationalism was now suicidal folly. The only salvation, he believed, was a supranational authority with power to prevent war. He also became a fierce defender of civil liberties in his adopted country, speaking out against the Red Scare and McCarthy-era witch hunts. He saw intellectual intimidation and demands for political conformity as a frightening echo of what he'd seen in Germany. He advised people called before congressional committees to refuse to testify, an act of civil disobedience that brought a storm of criticism down on him. But he remained unbowed. Freedom of thought, he believed, was the lifeblood of a healthy society. He lived out his final years in quiet Princeton, a living landmark, a gentle, rumpled figure with a booming laugh who'd help local children with math homework. He'd grown closer to his son, Hans Albert, who became a respected engineering professor. But he was haunted by the tragic fate of his younger son, Eduard, who spent his life in a Swiss asylum with schizophrenia. Einstein never saw him again after leaving Europe. His last public act was signing a manifesto with philosopher Bertrand Russell, urging all nations to renounce nuclear weapons. He died a week later, in April 1955, at 76. By his bedside were 12 pages of equations, his final, unfinished attempt to find his unified field theory. He died as he'd lived, still searching, still wondering. So what do we take away from this incredible life? What lessons does Albert Einstein, this gentle rebel who remade our universe, offer us today? It seems to me there are a few simple yet profound truths that shine through Walter Isaacson's magnificent biography. First, and perhaps most importantly, is the power of curiosity. Einstein often said he had no special talents, only that he was passionately curious. Think about that. He didn't see himself as a superhuman intellect, but as someone who never lost that childlike sense of wonder. He questioned things adults learn to take for granted. Why does a compass needle point north? Why is the sky blue? What would it feel like to ride on a beam of light? He shows us that the greatest breakthroughs don't always come from having the most knowledge, but from asking the most fundamental questions. It's a powerful reminder to never stop asking why. The second lesson is the courage of nonconformity. Einstein's entire life was an act of rebellion. He rebelled against his German schools, rigid discipline. He rebelled against the academic world's stuffy conventions. He rebelled against common-sense physics accepted for centuries. His genius was inseparable from his willingness to be an outsider, to think differently, to sail against the current. In a world that often pushes us to fit in and follow the rules, Einstein's life is a powerful argument for the creative power of being a little different, of marching to your own beat. But his rebellion wasn't destructive. It was what Isaacson calls a reverential rebellion. This is the third great lesson. He could tear down Newtonian physics pillars, but did so with deep, almost religious awe for the universe's harmony and beauty. He believed in an underlying order, a spirit vastly superior to that of man. This combination of rebellious questioning and humble reverence made him so unique. He had confidence to challenge the old, but humility to be in awe of the mystery of it all. He wasn't just trying to be clever, he was trying to read the mind of God. And finally, there's the beautiful connection he made between imagination and reality. He didn't come up with his theories by poring over experimental data. He came up with them through pictures, through thought experiments, through what he called great forward leaps of the imagination. He could visualize what it meant for space to be curved, for time to be relative. For him, imagination wasn't just fantasy. It was the language the universe was written in. As he famously said, imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world. So how can we apply these lessons in our own lives? It's simple, really. Stay curious. Ask the obvious questions. Don't be afraid to challenge conventional wisdom. And never, ever, let go of your imagination. Nurture that sense of wonder you had as a child. Look at the world with fresh eyes and remember that behind the everyday, there's a universe of mystery waiting to be discovered. That was a summary of Einstein, His Life and Universe by Walter Isaacson. We've touched on the major moments of his life and the core of his ideas, but a brief journey like this can only show you the highlights on the map. The real adventure comes from exploring the territory yourself. The beauty of Isaacson's book is in the rich details, the personal letters, and the intimate stories that bring this incredible man to life. If any part of this story has sparked your curiosity or made you wonder, I truly encourage you to pick up a copy. Reading it isn't just learning about a great scientist. It's an experience that can genuinely change how you think about creativity, genius, and the universe we all share. You'll find a link to the book in the description below. Also, if you found this summary valuable, please take a moment to click that subscribe button. It helps us continue bringing you these deep dives into the books that have shaped our world. Let's keep learning and keep wondering together.